Okay, this is the last part of our notes on graphing sine and cosine functions. If you're in my class, in the notes you'll see some pictures of graphing a sine function with a really small period that shows you it's really important that you get a window to where your scale matches the period, or a calculator or computer might produce a picture that really just looks like garbage because it's oscillating so many times it just can't handle it. So it's really important when you graph trig functions, use the period to label the x-axis or to pick a scale for the x-axis. Okay, the last thing I want to point out here is just kind of, for my pre-calculus class, I'd say it's just kind of an interesting fact that sine and cosine are both trapped between -1 and 1. So if you multiply by another function, particularly if that function is positive so that we don't have to worry about the inequality signs changing, then a function times sine of x or cosine of x would be trapped between negative f of x and f of x. So I'm going to show you a couple of pictures just on the calculator here. Okay, so we're going to do 2 times e to the x, negative 2 times e to the x, and then a graph that's trapped between them, 2e to the x times sine of x, and I've told you one window you could look at it in. So let's do y equals 2e to the x and negative 2e to the x. I'll go ahead and graph those, and you see it makes kind of a funnel shape. You've got the exponential growth function, and then its reflection makes what looks kind of like a funnel. Let's change the window. I said to do -5 to 2 in the x direction. The first coordinates are the x's. And then -12 to 12 in the y direction. Might want to change the scale on the y-axis, but it's not a big deal. And then finally, the whole point here is if I do 2e to the x times a trig graph, we're going to do sine 2x, and the 2 just changes the period, but we get a graph that oscillates between those two graphs. And it's hard to see a lot of this graph. If you zoom out further, you'll see it just keeps bouncing between them over and over. And then similar, if we look at 1/2 x squared cosine 3x, I'm going to do 0.5 x squared, negative 0.5 x squared, and then 0.5 x squared times the cosine of 3x. I'm going to go to standard window. We see that the cosine graph oscillates between the positive and negative of the function it's been multiplied by. Okay? So just kind of an interesting fact. One last slide here. This one becomes really important in calculus when you start looking at the derivatives of sine and cosine. But if you look at sine x over x, it's actually undefined at 0, although just to see the graph, it oscillates between the graphs. I only put 1 over x here, but if you did -1 over x, you would see that the graph of sine x over x is trapped between those. An interesting fact that you need in calculus is even though this is undefined at 0, the graph clearly approaches 1 when you zoom in on it. So that's our introduction to the graphs of sine and cosine. You want to know how to plot sine and cosine on one complete period by basically using the 5 points that we've seen. With sine, you get one hump going up, one going down. With cosine, you get more of a U shape. And then you want to be able to do transformations, and the vertical stretches and shrinks relate to what we call the amplitude, the height of the trig graphs. The horizontal shifts we call phase shifts, and when we change the period, or when we do horizontal stretches and shrinks, we call that the period. The period's 2 pi over k.